Good morning. We're continuing to look at example 2 out of section 1.5, best fitting curves. We're looking at the consumer price index and trying to fit an exponential curve to it. What we found last time is when we fit the exponential curve, the best fitting curve is something that we look at and say, that doesn't look like a very good fit. And part of it is an exponential curve assumes a constant rate of change. And when I look at the rate of change, there's a lot of numbers that are around 2 or 3% change in the consumer price index. But when we get down to 1983 or 4, suddenly the numbers are really large. From 83 back to 73, they're 6% to 13%. So there was a huge inflationary period there, and that's where the curve's gone off. And so what we're seeing is something that's not mathematics, but what we're basing our model on. If we assume the consumer price index increases by relatively the same amount every year, something happened in 73 and something happened in 83 that fundamentally changed that. So we're not going to get a very good fit. But if I look at it, the numbers after 83, the change after 83, those are all 2 or 3 or 4%. So I'm fairly confident that if I do my adjusted year versus the consumer price index and look at the period from 83 to 2011, that should give me something that's a much better exponential fit. I want to highlight the two columns back to 83. I'm going to take that and insert my scatter plot. And then I'd like to find an exponential fit for that. I'm going to add a trend line, make an exponential curve, display the equation on the chart, and notice the equation looks like a much closer fit then. And I'm willing to say that looks like it might be an exponential fit with a different value there. So I'd like to take it and change the size of my font, make it so it's easy to read. I'm going to make it a 16-point font. This now gives me an equation that I can once again try and make a projection off of. And I face the same things I did before. 104.36 times EXP of 0.0287 times X. And X is my adjusted year, so B2. And this should give me a much better fit than the one I had before. I'm going to move my tables off to the side, my charts off to the side, and we're getting things that look like they're in the right ballpark to be what our examples were. So 96 to 101, 103 to 107, it's a much better fit this way. So one of the things when we're trying to fit data to models is the models are based on assumptions, and we have to know real world information to know that. So something happened in a period of years where the inflation rate went up, and that changed it, not making it a good exponential model. But if the inflation rate is relatively constant, we get a good fit and can make predictions and values based on those values. Thank you.